introduction. Good morning. It's great to be here to tell you about our work in content provenance and how it can help indeed fight fake news and misinformation, but also help ensure safe and fair use of generative AI. So, what do we mean by, first of all, generative AI? Well, generative AI, I guess, is a recent term to describe AI models that create content. Actually, we've had AI models that create content for at least 10 years. There was some, work, initially GANs and these other kinds of neural networks that could create very low resolution images of one particular thing. I think bedrooms perhaps was the first example, trained out of IKEA catalogues and things like this. But these days, of course, our models can do so much more, and I could have chosen any kind of examples here, but I've chosen one of the early text-to-image models that show that we can generate a diverse range of content from natural language prompts, and more recently, examples of generating videos from the same. So generative AI is all about creating content using AI rather than the complement, which would be making decisions using AI. So, so what is driving these huge advances in capability then over these last few years? Well, primarily it is the availability of data. If we look at the number of parameters that these models learn internally as they're being trained, we're looking in the order of 10 billion or so for the kind of contemporary text-to-image models. These are models that create images. If we're looking at LLMs, large language models, as Peter was introducing, we can see that the order of magnitude is at least an order of magnitude higher in terms of the number of parameters, over 100 billion in many cases. So it's reasonable to ask then, where is all the data coming from that is being used to train these enormous models? And of course, the answer to that question does depend very much on who's training the model. But primarily it is being sourced for the very largest models from the open internet, from the public data sources. And that, of course, then raises all sorts of questions around whether we have permission to train AI on that data, what are the rights associated with it, the consent that has been given by creators for that purpose. So as ever, technology is ahead of legislation, but we are starting to see legislation catching up. There is, in fact, the EU Copyright Act, which was written in 2019 before generative AI was coined as a phrase, but certainly not before people were generating with AI. And the Copyright Act has a particular article in it, Article 4, talks about text and data mining, or TDM. Basically says that if you're non-commercial, you can train on copyrighted data. If you are commercial, you still can, provided people have not opted out, and this is called the TDM exception. There's also more recently the EU AI Act, which again relates to disclosure of training on copyrighted data. I'll come back to this legislation later on, but to sort of summarize, data is driving advances in these models, and increasingly we need to worry about where that data is coming from, and that is, of course, the problem of provenance. So what do we mean specifically by content provenance? Well, provenance is the origins of something, so in this case the data or media that it's being used to train the AI model. It doesn't just mean where the data's come from, it also means who created it, what has been done to it, in the case of images, for example, how they've been edited, and also maybe who's done that as well. So one of the So why do we care about this? Well, because as Peter again introduced this morning, the data directly impacts the capabilities and behavior of the AI model. What are some of the challenges and emerging techniques around data then? Well, perhaps the most well understood one is training data bias. As we heard this morning, AI models, they don't take a copy of the data they're trained on. They learn a statistical distribution from that data. And the process of creating content from an AI model is the process of sampling that distribution. And that means that any biases in the training data bias that distribution and therefore bias the output of the AI model. In other words, the learned distribution, it reflects the representation bias in the training data. So, what does that concretely mean? Well, I mean, this is just one of many examples I could have shown about the training bias. So in this case, there is an image classification model, an AI model that makes a decision about what kind of object is in an image. This is a model that has been trained on ImageNet, which is quite an old data set now of about 1,000 data types of object. And what we've done here with this model, or what the authors of this paper, I think from Google, did, was they generated images that were hallucinated that sort of maximally trigger the model to say there is a particular object class present. In this case, dumbbells are present, right? Weights that you lift. Yeah. And what's interesting about this visualization is that you run it multiple times. It's a sort of stochastic process, so you get a different result each time. But each result is showing not only the presence of dumbbells, but also an arm attached to them. And this tells us that the model has been trained on biased data. Every image of dumbbells, or the majority of images of dumbbells shown to the model during training, have also had an arm attached to them, right? And this tells us then that if we show the model an image that doesn't have an arm attached to it of dumbbells, it's not going to do as good a job of recognizing that image. Okay. How does this generalize to real-world scenarios? Well, let's suppose I have a self-driving car that's trained to recognize pedestrians in an urban setting, and all of its training data, or predominantly its training data, is from urban settings. I take the car out on a country road, and it's not going to do as good a job. All right? So these are some of the techniques that we can do to uncover bias in our training data. Another issue which was touched on this morning as well is the issue of memorization from training data. And this is particularly problematic in the case of generative models, because in the case of generative models, we can start regurgitating examples of our training data, which can be problematic to the creators who have contributed that training data to the model. As we said in the previous slide, the process of training an AI model is the process of learning a data distribution. And the more you oversample particular data when you train that model, the more the data distribution will be skewed towards that data and eventually will replicate that data. So this means that the more duplication we have in a training set, the more memorization of that duplicated data we will get. If you look at some works recently that will look to basically attribute a synthesized image to the responsible training data, and I'll come back to this work later, what you can see is in data sets like Lion, for example, which is an openly sort of scraped data set from the web used to train Stable Diffusion, which is one of the open models for text to image, what you'll see is that actually a synthesized image in many cases can be attributed back to near duplicate copies of that synthesized image within the training data. In this case, it's a watch that's been synthesized. You can see that, in fact, there's very close visual examples in the Lion training set because it's been trained from openly scraped product catalogs and things like that online. Another challenge we have is that other models that have memorized styles. So we call these concepts in general. Could be content, could be styles. In this case, the visual style of living artists. And that's problematic, of course, for those artists who make a living by selling their work. So this is certainly one of the big challenges, this idea of concept memorization and an imitation of the model. But also another challenge is the use of AI models to generate visually plausible data that is in fact a lie or fake news, as it's often referred to these days. I could have chosen so many examples to illustrate this. Perhaps one of the most famous contemporary examples is the Puffy Pope example, which I guess many people will have seen in the media. But there are, of course, many other examples. Indeed, the issue of fake news is not a new one. People have been lying or generating fake news, most likely since the advent of the spoken word. I like to show this slide in some of the talks I give. It's a photo I took from the UK's National Archives of a proclamation against fake news or false news from King James II's time. This is one of our first projects we did actually with the National Archives on Provenance. It's a long-standing problem, but certainly a problem that has been exacerbated with the advent of AI, in other words, democratization of the ability to generate visually plausible misinformation, and also with content platforms like social media platforms that exacerbate the speed at which that information can be shared. So the sort of thesis I'm putting forward to you today is that all of these problems, the problems of assuring the quality of data in an AI model and the problem of fighting fake news and misinformation, can be solved or at least strongly addressed by knowing more about the provenance of data and media, in other words, where it's come from. There's a lot of great work out there that is looking to fight misinformation, particularly visual misinformation, by detecting the use of AI and the generation of that content. We call these detection methods. You're either detecting synthetic content or you're detecting manipulated content. That's fine, it's a perfectly valid way to go, but it isn't going to address the whole problem. There's a lot of manipulated content that has been created by authentic actors, legitimate actors, that isn't fake news at all. If you think about tools like Photoshop, it's typically being used to edit content for good, to disseminate, to tell authentic stories. Even generative AI, in general, people are using it to create content to reinforce authentic stories they want to tell. It is not always, of course, or even in the majority of cases, used to create bad content. So most manipulated content is not misinformation. And then if you look at the flip side of the argument, you talk to human rights organizations like Witness.org, they will tell you in reports like their Ticks or It Didn't Happen report from 2021, they'll say things like, most visual misinformation out there is not manipulated at all. It's unaltered imagery that has been used to tell an alternative story, like a misattributed image, a miscaptioned image of a photo, for example, of an event that's happened that's being used to tell a completely different story. So that intersection then between misinformation and manipulated content is actually super small. If you're trying to fight the problem of misinformation in that intersection, you're basically trying to fight it with detection. You're in an arms race with generative AI, and nothing moves faster at the moment than generative AI. So our approach then is to try and inform users, give them more informed context about where content has come from so they can make the appropriate trust decisions themselves rather than us create a detector that tells them true or false. So this is how provenance can help. And one of the big ways that we've been driving this argument, both commercially at Adobe, but also many other partners, as I'll come to describe, is to create an open standard for describing the provenance of media and more generally of data. And this standard is being built by a group called the Coalition for Content Provenance and Authenticity, or C2PA, and the standard also is called C2PA, but its user-friendly name is Content Credentials. What are content credentials? They're basically data that lives, is what we call metadata, inside an asset that travels around with the asset and describes an audit trail of where that content has come from, okay? We call that metadata a manifest, and it contains basically a cryptographically signed secure structure called a claim, which contains provenance facts called assertions. And those facts can be things like, how an asset was made, by who, even using what other assets, what ingredient assets. And as such, this manifest can create an entire provenance graph telling us how an image was made, from what, by whom, and so on. In other words, it's history. And there's a whole bunch of tools now that read and write this metadata. If we look at who's involved in C2PA, this slide actually is out of date now. It's hard to keep it up to date because so many companies are joining this coalition every week. But we've had, just this year, it's been obviously a big year to address things like election misinformation and so on. We've had many companies join, Google, OpenAI, even Meta, TikTok. There's a lot of people adopting this standard, and we can see it now in at least 4 camera manufacturers' firmware, so cameras that actually write this information into photos they take. We can see it inside tools like Photoshop that manipulate content, and we even see it in some websites, like, for example, LinkedIn will surface that little content credentials icon if someone has posted an image containing content credentials, although most social media sites don't do that yet. So in fact, therein lies one of the biggest challenges for C2PA, which I think everyone openly recognises, which is as a metadata standard, like any metadata standard, it is only going to work well if content platforms persist that metadata as it's shared through them. And most content platforms do not. So what we can do in those situations is use what we call fingerprinting, taking a digital fingerprint of an image that helps us identify it and can help us then recover metadata from a secure location if we encounter an asset that is circulating online that's, for example, been posted on social media that has stripped its metadata. Okay? So this is a good example. Many generative AI models, including Adobe's Firefly, will write now C2PA metadata into those content credentials into images that they generate. So DALL-E does it, Firefly does it, and so on. What at least in Adobe's system we do is when we write that metadata into the image, we keep a copy of it indexed by that fingerprint. And then if that image is placed anywhere online, even if you take a photo of it off a display like in a cafeteria, it will let you look up that metadata, restore it to the image, and let you make a more informed decision then about the provenance of that content. So this is great and actually outlines why metadata on its own is not sufficient. We need to actually reinforce the metadata with techniques like fingerprinting to make it more durable so it doesn't get stripped from content. That example I gave you there involved dragging an image into a tool that did that lookup using a fingerprint to recover the metadata. But in general, we can't expect users to be forensically dragging images into tools to inspect everything they see, particularly on social media where the decision to reshare content is often quite instinctive and quick. So we need a kind of a third technology, which is watermarking. So the distinction between fingerprinting and watermarking is a little bit subtle. Fingerprinting is about passively extracting a hash from an image that you can use to go look up the metadata. Watermarking is about inserting an invisible identifier actively into the image that lets you go and look up that metadata. Okay, the two are two different ways of approaching the same problem. That's particularly important when you're thinking about making something like a web browser implementation of this technology, where you might go and use that identifier to go and look up that metadata. So in this case, we've got an image here that was generated by Adobe Firefly. It's a generative AI model. Inside that image is an invisible watermark, and this browser extension has used that watermark to transparently go look up the metadata, restore it, to allow the user to then find out more about that image, even though this particular social site has stripped that metadata off the image as it was posted to that site. And this is really just going back to this slide, why we need all three of these technologies to create a solid provenance layer. Metadata, very easy to strip, but it is cryptographically secure and you don't need an internet connection to check it. Fingerprinting is impossible to strip because there's nothing to strip, but you do need an internet connection to go look it up, and it requires that network call to do so. Watermarking is kind of a blend between the two. It is possible to strip a watermark, but if you're an adversary, but if you've got a robust watermark, it will persist through, for example, social platforms. And you do still need the network connection to go look it up. But critically, you don't need to ping every image in a web browser situation to a server to go check it. You only need to look up images that have a watermark detected within them, and you can make that detection on the client side, which helps ensure the scalability and privacy of the solution. One of the innovations we've produced in our group in order to drive adoption of this approach is to create an open-sourced watermarking technology. Quite a lot of watermarking technologies are proprietary. We created a high-quality watermarking solution and released it under MIT open source license to help people ensure the durability of this open standard. Our technology is called Trustmark. What we've got here on this slide is a difference between an original image and a watermarked image. You can't see the difference, but if I subtract the two and create a difference image and then amplify, you can see what we call the residual, which is basically the encoding of that identifier in the image. And what we have with Trustmark is what we call a much lower frequency encoding, which makes it much more resilient to the sorts of transformations that social media sites will perform on the content as it's circulated online. This diagram shows an even more general solution, which is to think about these durable credentials in a more decentralized world. So in the examples I've shown you there, these were proofs of concept that used Adobe's cloud to go look up that metadata. But of course, we don't anticipate a future where one company somehow becomes the police for the world's media. It's obviously a very bad idea, in terms of scalability, liability, and privacy. So in reality, we have many companies actually standing up these durable content credential solution, and it would be fantastic to be able to federate the search across all of those manifest stores, those metadata stores, in order to do this recovery. And one really interesting prototype that we've been exploring has been using distributed ledgers, or blockchain as it's referred to, in order to create a decentralized database to perform this lookup. So for example, the browser extension detects a watermark, it goes to this amorphous kind of cloud or distributed database to figure out which endpoint, which company it should go talk to in order to recover that metadata and display it to the user. So this is a kind of an exploration in progress, but it is, I think, a really interesting way to take this work forward. This then opens up a couple of other brief sort of future possibilities for this work. One really important issue, as I said at the beginning of the talk, is the issue of consent in AI training, and in particular the ability for creatives or people in general to opt out of their data being used for AI training. One of the features of the CTPA, or well, more specifically in more recent versions, a creator extension of CTPA, which is called CORG, is basically the ability to express opt-out using this metadata standard. And if you think about this lookup process I just outlined now, that could then very easily be used to look up an indicator as to whether people have opted out or not from training data. This is, there are lots of different ways we can opt out. People have been exploring opt-out at the point of scraping online, using things like a sort of a variant of robots.txt, which is the usual way of people sort of stop people crawling their sites. People have been proposing things like an AI.txt to stop people crawling for AI. That's really important actually, because creatives often want their content to still be indexed by search engines, but just not used to train AI. So that's why people are exploring this alternative. Metadata, as I've just described, and then having some sort of decentralized registry for that metadata. And yeah, this is a really interesting area, particularly in the EU. This is a workshop, a photo from a workshop that was discussing this issue. And one of the really interesting things that came up at that workshop was the need for greater granularity. Creators perhaps want to have their content used for certain AI uses and not certain others. The language is very binary at the moment in the legislation, but the language being used in some of these emerging metadata standards is a lot more granular and interesting. The sort of last opportunity I want to outline for provenance is actually going beyond looking at its use to fight misinformation or even the ability to assert consent and rights over content, but actually the opportunity to unlock new value creation chains through provenance. In this example, we have a generative AI model that has been asked to produce an image of a fun 3D elephant. And this model has been trained, in this case, over a stock photo collection. CTPA can be used to assert which data set that model has been created from. And then we can use other techniques, like data attribution techniques, to figure out what subset of that training data is most influential in the creation of that image. And then we can do other things like, for example, determine the owner through provenance information again, and maybe even issue micropayments to that creative for the generation of that image. So it's like an entirely new way of creating value from data. This is a slide showing some of our research we published last year, where we have a synthetic image from a trained AI model, and the training images used to create that AI model. And the scores being shown here are attribution scores that tell us how responsible those training images were for the generation of that particular synthetic image. So you could imagine how, in the framework I just showed on the previous slide, you could put the two together to create like a new compensation model for creatives as another idea that we've been exploring at the university. So in summary then, provenance, enacted through standards like C2PA, the metadata, but also reinforced through fingerprinting and watermarking, gives us this solid layer where we can say something about the origins of data, who created it, and so on. And once we can say something about that, we can also establish its authenticity and ultimately its value. And then looking at some of the closing slides there, we can use provenance to create decentralized markets for creative content and compensate creatives in new ways for the use of their data in AI, thus enabling safe and fair generative AI through content provenance technologies. So I'll end there. Thank you.
Wow, thank you so much. Thank you so much, John. That's, wow, lots to take in there. There's fascinating stuff. Do we have a question going? I'm sure, I know there's lots of questions. Sure. Here you go.
Thank you very much. Thank you for the great talk. That was pretty amazing. It was quite enlightening. Something did come to my attention that I've noticed that when you talked about the fingerprinting in particular, since metadata and watermarking can be stripped out in some way, either by cutting or stripping the metadata, I figured fingerprinting is probably the best way that you guys had at the moment. But something did come to my attention that I also had an idea potentially you could consider, which is potentially if the image itself is changed and the cryptographic hash is changed as well. Like by inserting a pixel in, for example, that would change the hash entirely. So I was thinking maybe you could explore using anomaly detection inside the image itself to detect if, for example, a pixel is out of place, or if like data is embedded inside it, to then also add more value to the fingerprinting itself mechanism. So then you would have even more robust solution. I'd love to hear your thoughts on that.
Oh, wow. Not a question, a suggestion. Thank you.
Thanks for the question. Yeah. So although I didn't have time to go into the details of fingerprinting there in the talk, I think your question gives me the opportunity to make an important point about it, which is the fingerprinting is robust to the kinds of non-editorial transformations that social sites and so on would typically make to the content as it's shared online. So for example, social sites almost always will rendition the content into a lower resolution. Typically it'll get a bit blurry, a bit noisier, that kind of thing. So for the fingerprint, it doesn't matter. It will always give you the same fingerprint regardless of those transformations. So in that sense, it is more robust than a cryptographic hash like a SHA hash or something, where even just a single bit of the image changes, the entire hash completely changes. So that is actually what a fingerprint is. It's like a perceptual hash, as we call it. Now, one of the challenges with perceptual hashes is that they're not absolutely exact or deterministic, right? So it can be the case that an image that is very slightly different, has been manipulated very slightly, might give you the same perceptual hash and you wouldn't want it to. And that's why we need to reinforce it with the other pillars of the provenance argument. So yeah, thanks for your question. Yeah.
So I'm a little bit worried about the use of the blockchain, because the last time I looked, the blockchain consisted of less than a terabyte. It has a 10-minute latency, and it uses nearly 1% of the world's energy. It seems a terrifically inefficient way of storing information.
Right, thanks for the question. So, well, the first thing I just want to reinforce is that actually, bar the one slide I mentioned blockchain on, none of the technologies that I've described today actually use blockchain. What I was suggesting is that blockchain, or more accurately, distributed ledger technology, offers a way to create a decentralized database to do the lookup of stripped metadata. Now, on that point, as I say, distributed ledger technology, or DLT, is the right word to use here because it describes a family of such blockchain technologies. Blockchain actually very specifically refers to the Bitcoin blockchain, which is the very first blockchain created, which indeed has all of the negative properties that you've outlined, the high expense, the long latency, the energy cost. Most contemporary distributed ledgers do not have that problem. They're what we call proof of stake ledgers, which are low energy, have very low latency and low cost. even Ethereum pivoted to that model like a couple of years ago in the merge and this kind of thing. So I would certainly advocate for solutions as we did to use a proof of stake approach rather than the sort of proof of work blockchain that you outlined in your question. Yeah.
Question from the back of the room here.
Hi, great talk. Some of us in academia are struggling with educational plagiarism. And we have no idea whether students who are submitting work is generated by AI, is the research being generated by AI? Is there a possibility that Adobe can come up with a plan to fingerprint PDFs, things that students generate, so it kind of stops propagating around the world for free?
Did you hear that, students? Okay.
Well, yeah, I think that's a really interesting question in the broader context of how can this technology help us fight plagiarism and academic misconduct. I think one of the really interesting things that we can do here is help, for example, in academic papers, if people were reusing images or perhaps even fabricating images, like it would be really interesting to see an instance of this metadata solution be put into like microscopes, for example, as they took images, so we could trace the provenance back to a sensor. We knew that images hadn't been doctored in their use in research papers. I think that would be a really novel and interesting application of some of these ideas. Your specific point about plagiarism, well, that is actually a value judgment that you make over someone's work, and we are very careful to steer clear of that. The mission of content provenance, if you like, is about ensuring a secure audit trail that describes where content's come from and what's been done to it. We don't say whether you should trust that content or not. An image I didn't show, but I often show in these talks, is there's the Cottingley Fairies, right, which is like a photo from the 1920s of basically cardboard fairies at the end of a garden, okay? And what I say is that is clearly a fake news, right? Maybe one of the earliest visual fake newses. But content provenance technology would tell you nothing about whether fairies exist or not. It would just tell you whether that image had been taken with a CTPA-enabled camera and the whole integrity chain was there. It doesn't make a judgment about the content of the image. And in the same way, I don't think this technology could really tell you if some work has been plagiarized or not. It can just tell you what the sources are of that work so that you can make a more informed decision as an academic about whether the work is plagiarized or not. And certainly in the visual arts, there's a very fine line between paying homage to a piece of artistic work and plagiarizing it and fashion too. So that is very much a subjective decision, yeah.
All right, so no quick fix, I'm afraid. So students, you have free reign. Okay.
Thank you. Thanks for the presentation. I think this topic is really challenging and very important nowadays. I have a question because you mentioned that, okay, the browser can identify whether the image was generated with AI or not, but I just can't stop thinking about a person like my father, for example, who has no idea about technology, and of course he will not go to the browser to see whether this is real or not. Imagine that he saw something on social media, Facebook, TikTok, Instagram.
Right.
So do you believe that in the near future there would be maybe, I don't know, negotiations or obligation, let's say, from the social media to tag the image that was generated with AI and said, okay, this one was AI generated? This is actually a main concern because the fake news spread much faster on the social media nowadays.
Yeah, what a great question. I think the point you make about your father there, and I think in general is a point about digital literacy, right? And I think it underlines how solving this problem is not actually a technical problem at all, it's a socio-technical problem, and the biggest challenge is the socio part, and in the advocacy and education around the use of these emerging tools, both the AI tools and things like provenance tools and how to interpret their results. On social media, I think the biggest challenge with social media is people resharing content without first stopping to think about whether that content is legit or not. And sometimes sort of draw analogy between that problem and the kind of Daniel Kahneman psychology model of like system 1 and system 2 thinking, right? Which is basically like a lot of our reasoning as humans is what he calls system one thinking, which is basically instinct. Right? Most of the decisions we make aren't thought through at all, they're just reactionary. Right? And very few of them are actually system two or thought through conscious decisions, which is a sort of remarkable statement, but it's a fantastic book, Thinking Fast and Slow. I'd recommend it if people want to read that. But it is the same problem on social media, right? When someone wants to reshare content, it's often very emotive content, it provokes a reaction, and people are like, reshare. If you can just stop people, or not stop people, just slow people down just a couple of seconds by providing them additional context about the provenance of that image, then that would be really helpful, I think, in helping fight the spread of misinformation.
Cooling things down.
Yeah.
Yeah, exactly. One last question we have time for.
Thank you very much for your presentation. I have a question, maybe it's two parts. First of all, maybe I misunderstood what you said, but social media has happened to strip off some data of images. Generally, they strip off the GPS coordinate, and you mentioned that you're able to reconstitute this. This is, to me at least, it seems like a worrying thing. And the second part of the question, if I was in Paris last year and I took a picture of Nike at the Louvre, and I noticed where I stood to take a picture of Nike of the Louvre, the next person stood exactly the same place and took the same picture. And if we both use the same Nikon 500, what's the difference between the two pictures, and who owns the provenance of these pictures?
Right, these are great questions. So I think the first question was in relation to the metadata stripping that happens on many content platforms, predominantly social media platforms. Yeah, they do strip metadata, including GPS, and they would strip in almost every case the provenance information from content credentials as well. The solution to go and look up that metadata presupposes that the creator of that image has decided or opted into lodging that metadata within a recovery service, which is certainly an opt-in service in everything that we've done at Adobe, but more generally, I would say should always be an opt-in service for exactly the privacy reasons you allude to. In fact, when you look at the content credentials standard, there is only one piece of one provenance fact that must always be included in that manifest, which is simply the hash that ties that metadata block to the pixels of the image or the data more generally, because it works on video and audio and PDF and other things as well. So there's absolutely no requirement to include anything about GPS in there. In fact, there's not even a requirement to include the metadata in a service that enables its recovery at all. It is down to the creator. So that's a really important point. I'm glad you asked that question. On your second question, you're basically talking there about hash collision of a fingerprint of basically two images that have been taken that are very, very similar, right? And that is why we need the three pillars, as I outlined, of provenance. So in the flow I outlined, what's happening there in the browser extension is we are reading an invisible watermark in the image, which is unique and would be distinct in those two cases of the two photographers taking the image. We are then looking up the metadata, and then as a security check right at the end, we are checking that the fingerprint inside that returned metadata matches the fingerprint taken from the watermark bearing image in order to avoid watermark spoofing, actually. So the fingerprint is not the unique identifier or key in the database here. The watermark is, and the fingerprint is just doing the check. So that would actually not be problematic in the scenario that you outlined.
So it's threefold. It's quite.
Yeah.
So, but using these tools, how optimistic are you that we can win the fight against fake news?
That's a great question. How win the fight against fake news? I think these technologies are a really positive step towards mitigating the threat of fake news and misinformation, and as I say, also helping with AI safety more generally. Fake news or misinformation, as I say, has been a problem, I think, since the beginning of the spoken word. People have always been lying, and I think people will always lie, and we will never stop lies.
Yeah.
But we can certainly help people make more informed decisions about the information they receive, and I think these technologies are making a really positive step towards helping us do that. Yeah.
Best of luck in fighting the good fight. So that's all we've got time for. We're going to go for a coffee break. And you sticking around, John? People can talk to you?
Yeah.
People can come up to you, ask you any questions?
I hope
they touch
so, yeah.
you?
Yeah.
Okay. They can do whatever you like.